Hello and welcome back. Today is day 10 of our Graphing Quadratics unit. We will be solving quadratic word problems involving maximum and minimums. Just a reminder, a handout of this lesson is provided in the description below. Thank you and enjoy. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. Hopefully by now you're starting to get the hang of these problems. This is a little review of what we did last chapter, so this should be a nice easy lesson. So again, you should be able to pause your screen and go through this whole lesson and then come back and we'll go over each one of the answers. But let's go over the do now right now. So let's sketch a picture. Draw a picture that represents a situation. A rocket is shot from a 40-foot platform. The rocket has an initial velocity of 200 feet per second. So the rocket is sitting on some platform. There's my platform. Okay, and let's draw a rocket. This is the rocket, and it has almost like an airplane. So there's the rocket. Perfect. And what do we know? We know that it is 40 feet here. So this is 40 feet from here to here. And we also know that the speed that it launches is going to be 200 feet per second. Okay, so that's what we know. We know how fast it is, we know the height, and so now the next part should be pretty simple. So let's write an equation that models the situation. So I need an equation to model the situation. So recall from last chapter, here's our vertical motion problem. So our height is going to be equal to negative 16 t squared. My initial velocity, so we're going to add a 200 t, and we are going to add the initial height. So the initial height was 40 feet. Okay, so that's the equation we're going to use for this problem. All right, now the rest of this problem you should be able to finish on your own, so go ahead, give it a shot, and then when you're done, return back here and we'll check our answer to make sure we got it right. All right, so for part C, when does the rocket hit the ground? Let's sketch a little graph of this. That always makes things a lot easier. So let's sketch a graph. So here's my graph, and this will be time in seconds. Okay, and this will be your height in feet. Okay, and what's going to happen with the rocket? Well, we know the rocket is starting on a platform, so it's going to be already 40 feet off the ground. So we already know that. We know the rocket's going to go up for a little bit, and then eventually it's going to come back down. So we're going to have a graph that looks something like this. And what are we looking for right now? We're looking for this point right here. When does the rocket hit the ground? All right, so let's try to solve this problem. So in this problem, let's see what we got here. So I'm going to write down my formula one more time. Actually, so what do we know at this point? We know the height is 0. So I'm just going to go ahead and start writing this out. So when the height is 0, what time is that? So let's solve this problem. So negative 16 t squared plus 200 t plus 40. All right, so let's solve this problem. Well, that's a review from last chapter. This is just solving quadratics. Go ahead and complete the square, use a quadratic formula, try to factor it. For me, the easiest thing that it looks like I can do, I mean, when I get numbers like this, I just like to use my quadratic formula. So I'm going to start with my quadratic formula, and I'm going to try to solve this problem, and I'm solving for t this time, not x. So t is equal to negative b, which is negative 200, plus or minus the square root of 200 squared minus 4 times negative 16 times 40. So I need to work that out. I'm gonna use a calculator for this one. I'm just gonna go to Desmos graphing calculator and then punch this into Desmos and see what it gives me. All right, so I'm gonna type that in there. So I'll simplify it real quick, just one step. So this simplified is going to be negative 200 plus or minus the square root of, it looks like 42,560. All of this divided by -32. And now here I'm just going to go straight to Desmos and then type this in Desmos and see what it gives me for an answer. All right. And when I come back, so my answers are, I have 2 times. I have 1 time is at -2/10 of a second, and my other time is at 12, I'm rounding, so about 12 and 7/10 of a second. So here's my times. So what does this tell us? This tells us that the rocket will hit the ground at 12.7 seconds. So I know that this point right here is going to be 12.7 seconds. And then the other y-intercept is going to be over here somewhere, but I don't really care about that. That's not going to make sense in my graph. So I don't really care about the -2/10 of a second. But the one I'm looking for is the 12 seconds. So about 13 seconds and the rocket will hit the ground. Question is question D. So what is the maximum height the rocket reaches? So what is the maximum height the rocket reaches? Oh, this isn't too bad. What we need to find is this point way up here. We need to find that point. And how can we find that? Well, we can just use the axis of symmetry. So if we can figure out where the axis of symmetry is, it's going to cut this right down the middle. If we can figure out where that is, that'll help us out. And remember, if something is in standard form, then the axis of symmetry can be found by using that little formula we found the other day. So x is equal to -b over 2a. So this will help us find the axis of symmetry. So let's find out what that is. So in this problem, so we're going to get x is equal to -200 over 2 times -16, which really becomes just -200 over -32. So calculator work in my calculator, that's going to give me x is equal to 6.25. Perfect. So now guess what? We know where the axis symmetry is. We know this is going to be at 6 and 25/100 of a second. So there's where my axis of symmetry is. So where's the vertex? So the vertex will be at 6.25, comma, and then the sum number. We need to figure out what that number is, and how do we do that? How are we going to figure out what number that is? So let me give us a little bit more room here. So I'm going to use, so now all I'm going to do is do a little substitution. So I'm going to substitute that 625 in for t and find out what the height is. So I'm going to go h is equal to -16 t squared plus 200 times t plus 40. So what I'm going to do is I'm going to put that 6.25 right into my equation where time is. So I'll add it in here. We'll multiply it, substitute it in there, and then I'll just evaluate. So again, using my calculator, this is going to give me h is equal to 665 feet. So guess what? Now we know the height of this rocket, the height the rocket will travel will be 655 feet. And that's after 6.25 seconds. So 6¼ seconds. Last question. At what time on the rocket's descent is the rocket at the same height that it started? So we're looking for, when does this rocket reach 40 feet again? That's going to be at this point right here. That'll be when it hits 40 feet again. That'll be the height. But what time is that? Well, this is the easiest problem. I mean, there's a whole bunch of ways we can do it, but I can just figure out, well, it took me 6.25 seconds to get to the maximum height, and then to get back down to the 40 feet, it'll take another 6.25 seconds. So that tells me that my time, we just need to double the 6.25. So 6, what is that, 12 and a half seconds. So it'll take 12 and a half seconds to reach 40 feet again. So it'll be at the same spot that it was at. And that makes sense. And another 0.2 seconds it'll hit the ground. All right, so pretty easy. This problem was nice and simple. And hopefully you enjoy this, and hopefully you're able to do most of these on your own. I'm going to use Desmos to graph this parabola and to see if our answer, to verify if our answers were correct. So let's type in the original function. So I'm going to use y is equal to -16. I'm going to use x instead of t, so x squared plus 200x and then plus 40. Okay, perfect. So that doesn't give us a good picture. So we need to change the window around a little bit, and let's go through this. So the first thing we figured out was, when does this rocket hit the ground? Well, the rocket hit the ground at 12 seconds, or at 12.7 seconds. And our graph doesn't even go to 12. The x-axis only goes to 10, so we need to change that around. So on the top right-hand corner, we're going to click the wrench. And now we can change some values in here. So I'm going to go a little bit larger than 12. I'm going to change my x values to go all the way to, let's go to 15. And let's see what happens. So I'll go to 15 and then I'll click on my graph. And now you can notice that the x-axis goes all the way to 15. But now I can see 2 points. And if I look right here, this is when it hit the ground. So I rounded it on my calculator, but at 12.6 seconds. And here was my other intercept. Yep, perfect. Now what I would like to see on this graph is the maximum height. I can't see that on the graph right now, so I'm going to have to change my window again. So let's go back to the wrench, and the y-axis now, we're going to go to the setting where it says y-axis, and we're going to change that. And remember that the height of the rocket was 665 feet, so I'm going to go a little bit larger than that so I can see the rocket, or see the graph nice and clear. So we're going to go 700. I'll change it to 700, and now perfect. And you can zoom out a little bit more and a little bit less if you don't like it, but that'll give me a nice looking graph, and look how beautiful that is. So if I look at my x-intercepts, there's the value that didn't make any sense. This other point is when the rocket hit the ground. Check out the 40 feet when the rocket hit 40 feet, and the maximum, that's when the rocket started. The maximum height is after 6.25 seconds at 665 feet. Perfect. And let me draw a horizontal line at y equals 40, so we could find the other point. And now you see how I created a blue line for us right there? Now we can see, oh yeah. So at time 0, when the rocket was just sitting, it was at 40 feet. And then 12.5 seconds later, it's at 40 feet again. And now I can see everything on my graph. All the key features, all the key points of this. So again, Desmos is beautiful, especially when you're looking at graphs to check your work, or just to verify what you're doing, or just to get a nice looking picture, so that way you can use it like a report or something. Alright, thank you. Hope you enjoyed the video. Till next time.